Hello guys, let's solve this problem. We will be given number n, and from 1 to n we must find the number of divisors for each number in this range and find the number with the maximum number of divisors. Find the smallest number with the maximum number of divisors. So until 20, if we have intrada 20, until 20, 12, 18 and 20 have the maximum number of divisors. Each have 6 divisors, and the smallest of them is 20, so we must print out 20. 12. Let's look to this presentation. So if, for example, I go from 1 to 20, I will create a vector with one more element than n. So if n is 20 and I have 20 elements, I will create a vector with 21 elements, so that I just skip position 0 and I can start using position 1 to 20. So for the number 1, I have only one divisor, so I'll say that for the 1, I have one divisor, and the maximum number of divisors is 1 so far. For the number 2, I have two divisors, so at index 2, I will write 2, and the maximum is 2 so far. For the 3, again, I have two divisors, so for the 3, I will write 2, and still I have maximum 2 divisors. And for the 4, I have 3 divisors, and for the index 4, I will write 3, and now my maximum becomes 3, and so on. I will continue for all the numbers until n is included. And as you see here, 12, 18, and 20 has the maximum number of divisors, which is 6. So after doing it, I will run through my array, through my vector, find the first number, the first element, which is equal to the maximum. So in this line, the first element which is equal to maximum is this element at position 12. So 12 is corresponding to my number 12. That's why I will print 12. So we can solve this problem in two ways. First way, I declare the number n. This is this number, and then I have maximum 0 and count 0. Count will be used in the loop to count the divisors. So I read my n, and I declare my vector with n plus 1 elements. And here in this loop, I run from 1 to n, for example, from 1 to 20. And every time in the loop, I make the count 0, because here I'm changing the value of count. That's why every time in this loop, I must my count to be reset. So in this loop, I just run from 1 until I. So first I run until 1, then I run until 2, then I run until 3, and so on. And on the way, if I modulus j is equal to 0, I will increase count. And then after this loop, I will assign count to the ith element of vector. And then if my count is bigger than max, so at the first run, it will definitely be bigger than max, because max is 0. I will assign count into the max. So the next round, if it is bigger than max, the count, it will be changed. And after I finish my operation, I will run through my vector, and I will check if vi is equal to max, and if it is, I'll print I. I'll print the position, not the value, and then I'll break the loop, because no need to go further. If you like, this solution works, but if you submit it here, you will get only 40 points, and the rest will be the time limit. So we have to optimize our solution. The optimized version of the solution will be that way. So the iteration of the array, so running through the array, like the last part, will not change. It's the same. The only thing which will change here is this inner loop, where we check all numbers from 1, but this time not until I, but until the square root of I. And then if it is divisible, then I'll do this operation. In the lessons, we explained how to work with this. So this is optimized solution, and it will give you the full points.